Good morning, all of you. Today we will look at angular variables. The first one we'll be looking at is angular displacement. So, the angle subtended by a moving body about a fixed point is called as angular displacement. Notice one thing here, that we are considering the motion of the body in two dimensions, or we are considering the motion of a body in one plane. So this here is our fixed point, and let us see what angle this moving body subtends at this fixed point. So observe that there is a body here moving in a random path in a plane, and we are taking where the body was initially, the initial position vector we are taking, okay, and we are also taking the final position vector, and the angle between these two at this fixed point is the angular displacement of this body. So the angle theta here is the angular displacement of the body about this fixed point. Now we have the same body moving in a similar path that it has moved, but we are going to take 2 points here. One is O1 and the other is O2. We are going to observe what is the angle subtended by this moving body at this 2 points. So we can say here that the angle subtended by this moving body with respect to this fixed point O1 is theta 1, and with respect to another point O2 is theta 2. So we can conclude that angular displacement depends on the choice of fixed point in the plane. So you take different points, the angular displacement of a moving body will be different. Now let us come back to our topic, which is circular motion. Let us consider this body which is moving in a circular path. Right, now if you are talking about the angular displacement of this body in general in circular motion, when we are talking about the angular displacement of this body, we take this fixed point as the center of circle. So we measure the angular displacement of this body about this fixed point, which is the center of circle. Another important point to remember is the SI unit of angular displacement is radians, or in short RAD. Angular displacement is also a dimensionless quantity. The reason being that it is the ratio of lengths, right? It is the ratio of arc length to the radius of the circle. So length by length. So that is why the angular displacement is a dimensionless quantity. Next, let us discuss the direction of angular displacement. We have discussed this in detail in a video which I am providing the link here. Also, you can find the video in the playlist Circular Motion Concepts. So the conclusion was the finite angular displacement is not a vector, and very small angular displacement is a vector. Now the direction of this small angular displacement can be found by using the right hand thumb rule. If we turn our fingers in the direction of motion of the body, then the thumb will point in the direction of angular displacement. Okay, so let us have a look at this. Right, so the body is moving in this direction, you are turning your fingers in that direction, and the thumb is pointing in the direction of angular displacement. So this is the direction of angular displacement. Notice I'm writing d theta bar here as very small angular displacement is a vector. Also observe one more thing, that this direction that you see here is perpendicular to the plane of motion of this body. If you remember, in rectilinear motion, the direction of displacement velocity was very intuitive. These vectors were along the direction of motion, or they were opposite to the direction of motion, which means you could visualize it. But you see in angular variables that this vector is not even in any direction of motion of the body, it is perpendicular to the direction of motion of the body. As this is not very intuitive, it will take a little time to get used to this.